You're in mute me.
Yeah. So good evening, all of you, first of
Good
all.
evening, ma'am.
And
Good evening.
so, this Zoom has an interesting feature now. It is a new change. The feature is that unless your video is on, I will not know. So every time I have to open the list of participants and see who all are present. So now I have opened the list and I can see Ashwin, Hariharan, Madhavan has opened his camera. So unless you open the camera, earlier, what used to happen is that if your camera is not open, then your visibility is there, but your name will appear, but your face will not. But now if you are not switching on the camera, I can't know. So when I want to ask you a question, children, my request is you should switch on the camera and answer, because I don't know who will be there and who will not be there in the class. So ideally you should switch on your cameras. If you have real difficulty, then I can excuse you, but otherwise, please, it will be good for you and also for me. Okay. So I got your answer papers of the previous test. So all of you have got the marks in the range of about 50%, around 20 out of 40, 16 out of 40, and things like that. So that's not great, but we have to slowly improve. This was your first test. So I can imagine you. I hope all of you have the marking scheme. Do you understand the mistakes that you have made, and do you understand, do you have any doubts, anything that you want to discuss? Today I'll give you some time based on, have you got your corrected answer papers back, all of you? Yes? Madhavan, I can see he's shaking his head, but all others, I don't know whether you're shaking your head. So you please say it aloud. Have you got your answer papers back? I think Hari Raghav, Vaishnavi, Ashwin, you should have got it back, right?
No, ma'am, we have to collect it from the academy, ma'am. So Monday we will collect.
Oh, so do you go to the academy to collect your papers?
Yes, ma'am.
And to write also, you have to go there?
Yes, ma'am.
Oh, I didn't know that. Okay. Anyway, I have got your marks, everyone. So I can tell you what you have got so that you know. But see, Ashwin, no, I should not share it while everybody is around. So don't bother. You will get it. So I can
we got our marks through app, ma'am. Only
okay.
the answer sheets we need to receive.
Okay. So when you go next time, you will get it. Okay, understood. So when you get your answer sheets, you will also understand where you went wrong, and please collect the marking scheme. And in case you want any clarification or any doubt, I have requested for a class next week where I won't be teaching anything new. I'll be only clearing your doubts from the previous 2 chapters. And we'll be doing more practice on those 2 chapters. Okay, so that you. So here is a question in continuation of what we did in the last class. We were doing calculation of want-off factor. And here there is an additional thing that we will do today, and that is to find out the dissociation constant. First, we will find out the want-off factor, and then we will find out also the dissociation constant. Okay, so let's see how to do it. First, all of you see the question and tell me how you would do the question. Now, in this case, one big difference is that the solute is a liquid, right? So you have to find the number of moles of the solute. First, you have to find the mass of the solute, because the density is given there. Okay, so this is a little variation. Density is given. What is the density? Density is 1.06 gram per ml. That's the density. Now, what is the mass? You can find out. So density is equal to mass by volume. You know that. So mass is equal to what? Density into volume. So what is the density? 1.06 gram per ml. And what is the volume? 0.6 ml, 0.6 ml. So what is the mass? This is 6.636 grams. Okay, so the mass of acetic acid is 6.36 grams. Right, so you know the mass of the solute. Now you have to find the mass of the solvent. So it is given, it is dissolved in 1 liter of water. What is the density of water? Sai Kalyan, what is the density of water?
Ma'am, it's 0.636 grams, ma'am.
Yes, you are right. Zero 0.636 grams, right. So what is the density of water? Density of water is 1 gram per ml. So 1 liter of water, if it is, so it is 1000 grams. And that is, so 1 liter will be 1000 ml, and that is equal to 1000 grams. 1 gram per ml is the density of water. So now you know all the data, please find out. So what is the formula that we will use? Delta TF, freezing point, is equal to I into, we have to calculate the want of factor. So that is I into, the depression of freezing point, dissociation constant. KB value is not given. I'll have to check that. Just 1 minute. TF is 1.86. This I forgot to type here. Delta T, KF. KF is equal to 1.86 Kelvin kilogram per mole. So I into, we have to write KF into WB into 1000 divided by MB into what? WA. Acetic acid, for acetic acid, molar mass is equal to 60 gram per mole. Now can you all do it?
Is it 1.04 approximately?
Yes. I is equal to 1.04. Did anyone also get that answer? So that we can be sure that Vaishnavi is correct. I also got the same. The moment you get the answer, children, you should speak out. Vaishnavi got it. Now I want to see others. Vaishnavi, can you find out the degree of dissociation also?
Yes, ma'am.
Sai Kalyan, today you are. Please confirm the answer. Did you get 1.04 approximately?
I'm doing.
Doing. Do it. See, for normally you all are not allowed calculators. So it is good if you are not using a calculator, but for the class note, so that we can get the answers quickly, please use a calculator. You can. So the answer is, this answer is correct. All of you can write down the answer. Those who did not get, did you at least understand how we arrived at this, all of you? Madhavan, did you understand? Hari Raghav, Hari Haran, did you understand?
Ma'am, yes, ma'am.
Understood.
Yeah. And what about
Yes, ma'am.
Sai Kalyan? Have you understood?
Yes, ma'am. Yes, ma'am.
Ashwin, did you understand? Okay. Okay, now we will do the second part of the questions. You calculated the want Hoff factor and the degree. Now you have to calculate the dissociation constant. So first for that, we have to calculate the degree of dissociation. So what was the formula for degree of dissociation? The formula for degree of dissociation, that is alpha, was equal to what? I minus 1 upon n minus 1. Okay, what is n? N is the number of particles which would have been there for complete dissociation. So in case of acetic acid, it is anyway, you know, it is weakly ionized. So you write a reversible sign. It gives you CH3CO minus plus H plus. It is a weak acid, right? So It is not completely ionized in solution. But if it was completely ionized in solution, what is the total number of ions? It would give 2. So N is equal to 2. So how will I calculate alpha? Alpha is equal to I 1.04 minus 1 upon N minus 1, 2 minus 1. So that is equal to 0.04. Or what is the degree in, if I have to write the percentage dissociation? This is a dissociation, degree of dissociation is 0.04, or that 0.04 into 100. Okay, so what is that? So the degree of dissociation of this is how much? Only 4%. Okay, so only 4% of the acid is dissociated. Rest of the acid is not dissociated at all. Did you understand this? So the value of I indicates that degree of dissociation is 4%. Ideally, what if it was 100% ionized, then what would have been, what should have been the degree of dissociation? It should have been 100%. This answer should have been 1. Right? Then it should be 100%, but it is not 100%, only 4%. That means out of 100 molecules of acetic acid, only 4 are ionized. So that is alpha, degree of dissociation. Now, using this degree of dissociation, we have to find the dissociation constant. Dissociation constant. Now, again, I will have to go back to what you learned in class 11. Have you learned about dissociation constant of weak acids in class 11 in the chapter of equilibrium? I'll ask you all one by one, otherwise I will have to explain, right? If you know it, then it's very good. Now, Vaishnavi, do you know, have you learned equilibrium in class 11?
Yes, ma'am.
You remember? Okay. Kalbagesh, have you done equilibrium in class 11? Chemical equilibrium?
Yes, ma'am.
Hari Raghav, Hari Haran, have you
Yes,
learned?
ma'am.
Okay. Ashwin, have you done?
Yes, ma'am.
Okay. Sai Kalyan?
Ma'am, they have taught chemical equilibrium, but I don't remember learning about dissociation constant.
No, you would have learned dissociation constant in ionic equilibrium. Ionic equilibrium chapter, you remember? How do you write a dissociation constant for? So I will show you. Now you will recall. I'm sure you have done it. So to write the dissociation constant, we have to write, let us write the reaction. So the reaction is CH3COOH at equilibrium. Whenever a reaction is in equilibrium, we write this symbol of equilibrium and giving CH3COO minus plus H plus. All right. So so initially, let us, when you began the reaction, initial concentration was, say, 1 mole of acetic acid, and this was 0 and this was 0. All right. Now when I alpha out of it dissociated. So at equilibrium, what will be the concentration of acetic acid? 1 minus alpha. What will be the concentration of acetate ions? Alpha. And what will be the concentration of H plus ions? Alpha. All right. Now, in case the concentration of acetic acid was not 1, it was C. Instead of 1 initial concentration, if it was C, or say initial concentration was N. Let me first complete with 1 mole only and tell you how to write the dissociation constant. So what is the dissociation constant? Dissociation constant, equilibrium constant. Supposing for this reaction, you have to write the equilibrium constant. How will you write equilibrium constant Kc will be equal to the concentration of the product divided by concentration of the reactant. So the concentration of the product at equilibrium is what? Alpha into alpha divided by 1 minus alpha. Okay, so 1 creates a little confusion. So let me make it C. Supposing the concentration was C. So C minus alpha, alpha and alpha. So final concentration is C minus alpha. So concentration of the reactants divided by the concentration of the products gives you the value of equilibrium constant. And equilibrium constant for weak acids, it is taken as Ka. Okay, so that is called the dissociation constant. Okay, so here in case of in this case, if the concentration of it is a very weak weakly ionized solution, the concentration of the H plus ions is very less, 0.04 only, alpha is very small. Then what we can do, we can say Ka is equal to alpha square by C, where C is the concentration. So we know alpha square. What is the alpha square? Alpha square is 0. Alpha is 0.04 into 0.04 divided by the concentration of the acid. Now concentration of the acid is given 0.6 ml per. So it is concentration of the acid is, we have to convert it into moles first. We have to get the concentration in grams per, in moles per liter. So how will I know the number of moles of acetic acid? This is the mass of acetic acid divided by 60. So that will give me how much? 0.636. It is 0.0106 gram per, no, moles per liter, right? It is moles per liter. Okay, so if I do that here, if I put that here, it will be 0.0106. Okay, so that will give me the value of Ka. So let us do that. 0.04 in Did all of you get the answer? Please quickly tell me the answer.
Ma'am, 0.15.
Now, one mistake that I have made. There is a small mistake that my answer doesn't match. Let me tell you the mistake. See, the mistake that I am making here is I changed the concentration here. I should have changed it in another way. See here, when I took 1, then this was 0 and 0. When I make it C, right, then this value alpha is This is not the correct way. Let me do this part once again. This dissociation constant part I will do once again. So this is CH3COOH giving CH3COO minus plus H plus. Okay, so initial concentration 1, then this is 1 minus alpha, then this is alpha, this is alpha. So if it is not 1, if it is n times, n moles, then this is n alpha and this is n alpha. So n is the number of moles of acetic acid. So if I take now Ka is equal to n alpha into n alpha divided by n. Because alpha, if I neglect in the denominator, then it becomes n. So I have to multiply by the concentration here. So this will become 0.0106 into 0.04. The whole square, I can say, divided by 0.0106. Okay, so the mistake that I am making is I have to multiply the answer with 0.0106 into 0.04. And if you want, you can do the way this one here also, but I am trying to make it easy so that you can quickly get the answer. So then the answer should be around something in 10 raised to minus 5, some value raised to minus 5. Can you find out now? Actually, you can cancel this n here. Did you get the answer, anyone? You will get approximately 1.7 into 10 raised to minus 5. So this is about the dissociation constant. Sometimes that is the most difficult question that can be asked here, but otherwise in the previous year's question papers, this has not been asked, but it is there in your syllabus. So I thought, let me do one question of that type. All of you got it? Vaishnavi, did you understand?
When we cancel the value of n, we will be left out with 0.04 square only, no, ma'am.
Yeah. Yes, 0. So we'll be left with 0.04 square, and then one more n will be there, no? I've written whole square, but here I have written 0.06 at the bottom.
Okay, ma'am. Okay.
The mistake that I was making was when I changed the number of moles to C out instead of 1, then here it should be C alpha, C alpha. So that is the mistake that I was making.
Ma'am,
Yeah.
how we should find the C, ma'am, C value?
N value, this N, how did we find? N is the number of moles of acetic acid.
Okay, miss. So it is 0.6 divided by 16, miss.
Yeah, 0.636 divided by 60. So
Okay.
that is approximately 0.01, you can take it. So if you want to do by approximation, that is also possible. So you will get something, then it will become 1.6 into 10 raised to minus 5. Even if you do approximation and get the correct answer, I mean, near about your steps are correct, you will get full marks. There's no problem. Shall I go to the next question?
Miss, one second, miss. I'm copying. I'm copying, miss.
Yeah. Ka will be equal to, if I take it as 0.01, it will become much easier. So it will be here the assumption that we have taken that the solution is dilute. So in the denominator, we consider that alpha is equal to 0, right? So that is why it becomes N alpha. N. In the denominator, I have written Ny because alpha is neglected in the denominator. So Ka becomes N square alpha square upon N. That is equal to N into alpha square. Okay, so it will, if alpha is equal to 0.01, then it will become 0.01 into 0.04 into 0.04. So 4 4s are 16. So 16, 1.6 into 1, 2, 3, 4, 5 into 10 raised to minus 5. 0.01. Okay, children, now I'll go to the next question. Now we will revise and what we have learned, let us see whether you understand now this question. Calculate the freezing point of a solution when 1.9 grams of MgCl2 was dissolved in 50 grams of water, assuming magnesium chloride undergoes complete ionization. Now, what do you understand by this question? Can you explain and do it? Now, when they are saying complete ionization of MgCl2, what do you think is the value of I? Anyone? What is the value of I here?
1.
See, what is the compound here? MgCl2. Right? What is MgCl2? Mg2 plus,
Ma'am, is it 3, ma'am?
yeah, it should be 3. So what are the number of ions after dissociation? 3. And before dissociation? 1. So what is the value of I? 3. All right. How do we calculate the value of I? Total number of ions after dissociation divided by the number of ions before, number of particles before dissociation. So number of particles before is 1 and after it is 3. So I value is 3. All right. Basically, if it is completely ionized, what do we have to look? I is actually the total number of particles which MgCl2 will form on ionization. So MgCl2 will form 1 magnesium ion and 2 chloride ions per molecule, isn't it? So what is the value of I? It is equal to 3. Now you substitute the values. Now it is given what a freezing point. So delta TF is equal to I into KF into WB into 1000 divided by WA into MB. Now tell me who will get me the answer first. You have to find the freezing point of the solution. Final answer only I want. Calculate the freezing point of the solution.
Ma'am, is it 22.32?
You are wrong. See, what can be the freezing point first of all? Anyway, your answer is correct. Only one decimal mistake you are making. Also, you should remember that you are finding, first thing is you are finding the value of delta T, TF, isn't it? Only value of delta TF you have found. So also remember that the change in, depression in freezing point or elevation in boiling point, these values are always very small. It is always less than 1. Rarely it will be more than 1. Okay, it cannot be 22. So if you are getting 22, that means, it will be generally below 5. The value should be below 5. So if you are getting 22, that means you are making some error. So check your answer.
Ma'am, 2.23.
Yes, 2.23. So 2.23 is what? It is delta TF, right? So what is the question? The question says you have to find the freezing point. So what will be the freezing point? You have got the delta T value, Vaishnavi, correctly. Okay. So what will be the freezing point is what you have to do. Okay. So delta T is what? T2 minus T1. Or you can remember, or you can say whatever is the freezing point. What is the freezing point of water? If you want to get the answer in Kelvin, what is the freezing point of water in Kelvin?
15.
No, freezing point of water. What is the freezing point of water? Do you know? At what temperature does water freeze? Pure water. What temperature?
0 degrees Celsius now.
0 degrees Celsius, which is same as 273.15 Kelvin. So this is the temperature of the pure water. Now, how much is the depression in freezing point? 2.23, right? So if I subtract, what will I get? I will get 270.92. So freezing point of water has become less than 273.13. So you subtract this value, you will get the freezing point of the solution. In case of freezing point, you subtract the depression of freezing point from the freezing point of water, right? In case of elevation in boiling point, what will you do? You subtract the boiling point of pure water from the boiling point of the solution, right? So that is how you have to be careful. Because elevation in boiling point means the new temperature of the solution should be higher than 100 degrees. Or 373 Kelvin. And in case of freezing point, it should be lower. Now, if you do all these calculations, did all of you get, or should I write delta TF is equal to I, which is 3 into KF 1.86 into WB 1.9 into 1000 divided by WA 50 into MB, magnesium chloride, molar mass is given here 95. So if you do all that, you get delta TF as 2.23 Kelvin. Why did I write Kelvin? Because this one is written as Kelvin kilogram per mole, so Kelvin. So that is why the freezing point will be of the solution will be from here, you get here, and you will get this as the answer.
Ma'am,
Yes.
I got the answer, but can you say me the formula, the trick to calculate I, ma'am?
Trick to calculate I here, there is, I will tell you. For calculating I, right? You have several ways. The easiest way to calculate I is you find the number, see, like for example, you find the number of molecules or particles which are formed on dissociation. So say, for example, if I take the simplest molecule, let me take another, or I'll do it because others are looking here. So NaCl, Sai Kalyan, it will break into how many ions? Na plus?
Na and Cl minus.
So what is I? It is 2, 1 plus 1, 2. If I take MgCl2, right, what will it break into? Mg2 plus 2 Cl minus ions. So what will be the value of I here? I will be equal to 3. If I take AlCl3, it will give Al3 plus 3 Cl minus. So what will be the value of I here?
4, miss.
It will be 4, right? This is the value of I if I am assuming that it is completely ionized. If it is completely ionized. If it is not completely ionized, I have to find the value of I in another way. What is the value of I? Then I use. It is always total number of particles after dissociation and total number of particles before dissociation. So if I do not know the whether it is completely ionized, in that case, say for example, I take NaCl. It gives Na plus Cl minus, that is equal to 2 ions. Okay, so if it is completely ionized, then I is equal to 2. But if it is not completely ionized, if it is completely ionized, 1 is giving 1 plus 1 completely. 1 mole is giving 1 mole of Na and 1 mole of Cl. So how do I calculate I? Total number of ions after dissociation, 1 plus 1, divided by ions before dissociation, that is 1. So that is equal to 2 by 1. So it becomes 2. Now, supposing it is not completely ionized, then out of 1, only alpha is ionized. Then how much of sodium ions? From 1 mole, only alpha particles are dissociated. So this will be alpha, this will be alpha. Right, so total number of ions, what will be the value of I? Total number of ions after dissociation, 1 minus alpha plus alpha plus alpha, divided by number of ions, number of particles before dissociation, that is 1. So I will, in that case, I will be equal to 1 plus alpha.
Ma'am, but how can we find whether it is completely dissociated or
That will be mentioned in the question. That will be
okay.
definitely mentioned in the question. Okay, now in this question, if you see, it is clearly mentioned. It is complete ionization. It is completely ionized. If it is not completely ionized, then they will say it is 60% ionized. So if they say it is 60% ionized, supposing in this same question, I had said it does not undergo complete ionization, it undergoes, if it had said, say, for example, it undergoes, instead of complete, it had said 60% ionization. Then how would I do the question? Then you will have to go here. And for here, what will I have to calculate? Value of I is equal to 1 plus alpha. Alpha is the degree of dissociation or ionization. So that is 60%. So 60 by 100. Okay, so that is 0.6. So value will be 1.6. Okay, so the value of I will become 1.6 instead of 2. So either the degree of ionization will be given to you, or the degree of ionization, if it is not given to you, you will have to calculate. That means it is completely. If degree of ionization is not given, you have to assume that it is 100% ionized. Or they will always write complete ionization or whatever. All right. Sai Kalyan, did you understand now how to calculate I?
Yes, miss.
Okay. Now in this continuation, supposing I had something which is associated, then also you should use the same trick to find the I value. So what is the I value? Say, for example, it is acetic acid. I told you the other day, acetic acid, it associates, not dissociates, but associates in solution. So if I take 2 moles of acetic acid, they combine together and give me a molecule which is 1, right? So if I had 1 of acetic acid, how many moles of the product do I get? 0.5. All right, 0.5. Why? Because 1 I had before, 1 mole if I had before dissociation, then after dissociation, after association, that 1 mole becomes 0.5 mole. So number of particles, what is the value of I? Number of particles after dissociation divided by number of particles before. So 0.5 divided by 1. So value of I will become 0.5. Okay. Or if I wanted to do it, if it is not completely associated, this means it is completely associated. If it is not, then out of 1, number of particles which have associated, how much it is? 1 minus alpha. Okay, and this one will become alpha by 2. 1 minus alpha and alpha by 2. So what will I be equal to? I will be equal to number of particles, total number of particles after dissociation, 1 minus alpha plus alpha by 2 upon 1. So I is equal to what? I will be equal to 1 minus alpha by 2. So if it is undergoing association, then you may have to use this formula, 1 minus alpha by 2. If it is undergoing dissociation, then you can say I is equal to, depending on each electrolyte. If it is sodium chloride, then it is 1 plus alpha. Okay, 1 plus alpha. You have to derive this formula depending on different electrolytes. Okay, so then if you have understood that, you should be able to do. Now here another question now. What mass of sodium chloride must be dissolved in 65 grams of water to lower the freezing point of water by 7.5 degrees Celsius? The freezing point depression Kf for water is 1.86 and want-off factor is 1.87. So here want-off factor is already given to you. So you can use that and calculate. So I will just show you, just do the steps, and even if you don't arrive at the full answer, copy the question, I will tell you the answer. So again, it is the depression of freezing point. So delta T F is equal to I into KF into WB into 1000 divided by WA into MB. Okay, sodium chloride is given here. So you can find, you have to find what mass. So this time you have to find WB. Okay, so TF is given. Depression in freezing point 1.86 is equal to I 1.87 into KF. No, depression in freezing point, I am sorry, it is not 1.86, it is 7.5 into 1.86 into 1000 divided by into WB, which we have to find out, divided by WA, that is 65 into MB 58.5. So the answer that you should get is 8.2 grams. So don't bother about doing the calculation. You can do later and see whether you get this answer. 8.2 grams. Yes.
Actually, they have given in the question that the freezing 65 grams of water to lower the freezing point of water by 7.5 degrees Celsius. They didn't mention the freezing point is 7.50.
I am not writing the freezing point, my dear. I am writing the depression in freezing point. Delta TF is what? He is saying lowering the freezing point of water by 7.5 degrees. That means the change or the freezing point has changed or become lesser by 0.5, 7.5, isn't it?
Okay, miss, but then we should write that in Kelvin only, no, miss.
You can see, Sai Kalyan, here, this value is already given in 1.8 degrees. See, it is a difference, you know. See, if it was, if you take the freezing point of water as 273.15, right? Then you change this value also. What will you do? It will be 273.15 minus 7.5. Okay, so the difference is the same, 7.5, isn't it? That this is whether it is in degree or in Kelvin, it is 7.5 only.
It doesn't matter, no, miss, it doesn't matter.
It doesn't, if you are taking the difference, it doesn't matter. Okay, but
Okay.
if you are finding the answer, if they ask you what is the freezing point and you have to calculate in Kelvin, then the difference has to be added either to 0 degrees or to 273, depending on what you have to find in Kelvin or in degrees Celsius. Okay, but difference is always, it doesn't matter. It is always the same, whether you take the difference in Kelvin or in degrees Celsius. So in one case, it will be 0 minus 7.5. All right. The other case, it will be 273 minus 7.5. This is a difference. Okay, so that should not matter. One case, your answer is in degree Celsius. In the other case, your answer is in Kelvin. But delta T will be always 7.5. This is neither in degree or in this, a difference. Okay, shall I go to the next question? Just one more, then I want to do some MCQs. Now this question I want you to do completely. Okay, so 1 molar aqueous, quickly you can do it because here the concentration is given, is heated to its boiling point. The solution has boiling point 100.18, determine the Van't-Hoff factor. Okay, so the boiling point of the solution. So boiling point of solution is how much? 100.18 degrees Celsius. What is boiling point of water? It is 100 degrees Celsius. Okay, so what is a delta TB, increase in boiling point? It is 100.18 minus 100, so that is 0.18. Now you put the values, delta TB is equal to KB into M into I. Okay, so how will I get 0.18 is equal to I into KB is given 0.512 into M1. 1 molar solution. So M is 1. So I is equal to what? 0.18 divided by 0.512. So you will get 0.35. 0.35. Now all of you pay a little attention. You will all get this answer without any problem. The value of I is 0.35. Now please see carefully. If the value of I is more than 1, right? If the value of I is more than 1, that means the solution, in the solution, the solute is undergoing dissociation. Right? That means the solution, in the solution, the solute is undergoing dissociation because one particle is breaking into more than one. So value of I is more than 1, that means the solution is undergoing dissociation. If the value of I is less than 1, that means in the solution, the solute is undergoing association. So what do you understand here? In this case, the solute is undergoing what? Association. That is why the value of I is less than 1. It is undergoing association. Do you understand? This is the first question we got for association. So if the value of I is less than 1, that means it is undergoing association. Now, if somebody asks you what is the degree of association? Degree of association. Okay, so for that I have given you the formula. It is I is equal to 1 minus alpha by 2. So what will be the value of I? What will be the value of alpha? Alpha here is degree of association. So 0.35 is equal to 1 minus alpha by 2. I'll do it here. So 0.35 is equal to 1 minus alpha by 2. So alpha by 2 is equal to 1 minus 0.35. So alpha is equal to is it 1 minus alpha by 0.6?
Ma'am, 1.3.
You got 1.3?
I
Yeah.
think like very much.
There is some mistake, I think. That means it is point less than 1. Just let me go back to the formula. This question, which is 1, my I is equal to 1 minus alpha by 2. So I we found as 0.35 less than 1. So alpha is equal to, you are getting 1.35.
No, just 1.3. 1.30.
1.3. Okay.
So,
Okay. So this is how you can calculate 1.3. Okay, so sometimes you may have to do a question like that. Okay, now let us see the next one. Okay, now let us do these questions here. Just for revision, I want to do this, then we will end this chapter and then we can clear our doubts in the next one. Osmotic pressure of question number 1. Osmotic pressure of a solution. You can all, writing these questions will take a lot of time. I'm going to make this worksheet and send these questions to you. Right now, you just answer. Okay, don't copy the question. Now, osmotic pressure of a solution is given at a temperature this. So concentration in moles per liter. Now, I want all of you to spend 5 minutes, 2 minutes. That is 30 seconds per question and write the answer of A 1, 2, 3, and 4.
Ma'am,
Huh?
for first one, is it option C?
Okay. I'll not say whether it is right or wrong, but Sai Kalyan is saying it is C. Okay. Tell me quickly. As you get the answers, please tell me. For the third question, I hope you understood. It is boiling point of 0.01 m barium chloride solution is about dash compared to, it is comparison of the two, 0.01 m of glucose. Is it the same or is it 3 times or whatever it is?
First one is C.
Okay, first one is C. Then value of Henry's constant. So 2 of you got C. Anybody else got C? See, what is the formula in case of others who have not done? The formula is pi is equal to C into R into T. So osmotic pressure is given as 0.0821 and we have to find C. R is also into 0.0821 into what?
300.
300, right? So this and this anyway get cancelled. So C is equal to 1 by 300. Okay, so the answer is C. That is correct. Now the second one, why you are taking so long to answer? The value of,
B.
huh?
Oh, sorry, B.
B, right? Value of Henry's constant, right, is different. First of all, it is different for different gases. Okay, so what is the solubility, the mole fraction is, we said, we learned that it is pressure is equal to vapor pressure of the solution. It is equal to KH into X, right? So KH is equal to P by X, right? So it will be larger for gases with lower solubility. Okay, I told you that day, remember that KH is inversely proportional to the solubility, the mole fraction. If it increases, that means the KH value is less. It's inversely proportional. Can you see this? Inversely proportional. So larger the value of constant, lower is the solubility. Okay. Then third question. The elevation in boiling point of 0.1 m barium chloride solution is, first of all, is it same as 0.1 molar solution of glucose? So you have two solutions. One is 0.01 m barium chloride and this is 0.01 m glucose. How will you find that? Sai Kalyan, did you understand this question?
Yes, ma'am.
Tell me, how many, what is the number of particles in 0.01 m barium chloride? Now, barium chloride is an ionic compound. It will ionize and give you 3 particles per. So this will be here, it will be 0.01 into 3. That will be the number of particles. And this is 0.01 because that will neither dissociate nor associate. So which will cause greater elevation in boiling point? The barium chloride solution will cause greater elevation. And how many times greater? 3 times greater. So the answer is C. Okay, so this is theory which you should understand. You can't always do it practice. And you don't have to do the numerical if you understand the theory properly. Okay, now the next question here. Considering the formation, breaking, or strength of hydrogen bond, predict the following mixtures will show positive deviation from Raoult's law. So this, if you revise, you will remember. I can just give you the answer here. Positive deviation from Raoult's law is methanol and acetone. Okay, here there is hydrogen bonding. Because of adding acetone, the hydrogen bonding breaks, so more vapor is formed. So it is positive deviation from Raoult's law. Okay, so answer is A. Please read. I will send the notes also today. Please read the notes, read from the textbook and try to understand this part. Okay. Next question. If a molecule AB undergoes dimerization in benzene, its Van't-Hoff factor is found to be 0.6. The degree of dissociation of AB is. Now it is undergoing dimerization means, what does it mean? It means that it is undergoing association. So if it is undergoing association, I is equal to 1 minus alpha by 2. So what is I? I is 0.6. 0.6 is equal to 1 minus alpha by 2. So alpha by 2 is equal to 1 minus 0.6, right? So that is 0.4. Alpha by 2 is equal to 0.4. So that comes to alpha is equal to 0.8. So that is 0.8 is into 100. That is 80%. So answer is C. In that case, why did you get 1.35? 0.35. So I was less than 0.35. So I have to get that. 65.65 into 2. 1 point. Did you understand this one? Now let us go to the next question. This one I have told you in the last class yesterday. At certain temperature, 5.12% solution of cane sugar is isotonic with this of an unknown solute, the molar mass of the solute. How will we do? I'll remind you, look at this, this slide if you see. I told you how to find. So you can find the W1 by W2 is equal to M1 by M2. You can separate, or you can say W1 by MB, M1B of first is equal to W2 by M2. So we can use this formula. Okay, so how will we put it here in this case? So this is 5.12. So what is the molar, what is the weight of the solute here? 5.12 in 100 grams. So 5.12 divided by the molar mass of cane sugar. You should know molar mass of cane sugar is 342. So divided by 342 is equal to molar mass of the other one, 0.9 divided by X. Okay, what did I say? W1 by M1 of 1 is equal to W2 by M2. That is a formula we've derived that day. So what is the value of X? X will be equal to 0.9 into 342 divided by 5.12. Some molecular formulae you should remember, cane sugar is 342, glucose is 180. So for MCQs, this will be a new thing. Now, children, whether you know it or not, I don't know, but the new syllabus, according to the new syllabus, according to the NEP, there is going to be a big change this year. And this year, 50% of your paper will be MCQs. So you have to, in fact, it's not clear, but the rumor is that there will be 2 papers of chemistry. One paper will be completely MCQs, and the second paper will be completely theory. Okay, so you have to learn the MCQs properly. So what is the answer that you get? Answer is A, 60. Children, do you all, I mean, like, we should, in your case, I should not say, because you have to learn to do it without a calculator. Now, which of these is not a colligative property? So osmotic pressure is, now this someone answer, please read and answer quickly. Come to question number 8. Tell me what is the answer. Hariharan has not answered a single question. Now tell me, which is not a colligative property? Who will tell me? Hariharan, are you there?
Yes, ma'am.
Tell me. Hariharan is not there. Hariharan Ganeshan is there. Hari Raghav has left. And Ashwin has left.
D.
Answer is D, correct. Okay, so this osmotic pressure, lowering of vapor pressure, depression of freezing point, which is the 4th one, elevation of boiling point, right? Now the 9th one, 12 grams of urea is dissolved in 1 liter of water and 68.4 sucrose is dissolved in 1 liter of relative lowering of vapor pressure of urea. It will take some. No, it will not. You have to calculate the number of moles because sucrose and urea are. So again, you have to do the same thing. Volume is the same. So relative lowering of vapor pressure, you have to find the number of moles. So 12 by urea is 60 is equal to how many moles? This is 12 by 60. So 12 divided by 60. So it is 0.2 moles and 68.4 divided by 342. Right? That is also, so 68.2 divided by 342 is equal to 0.2 moles, right? So the number of moles are the same. And sucrose and urea, you should know they are organic compounds. They are not ionic substances, so they will not dissociate. So the number of moles only will decide. You don't have to consider how it will dissociate. So since number of moles is same, the relative lowering of vapor pressure of urea will be equal to the relative lowering of that of sucrose. Did all of you understand these three questions?
Yes, ma'am.
Okay. Now I will, please, you don't have to copy the questions. Before I close, I want to tell you, Madhavan, your handwriting is very good.
Okay, ma'am.
I saw your paper. I was very neat work you have done. So I'll stop sharing. Before you all leave, I want all of you to switch on your camera for 1 minute. Madhavan, you can leave. Good. Others, I want to see you before you leave.
Thank you, ma'am.
Sai Kalyan, Vaishnavi, you can also leave. Good. You all understood everything?
Yes, ma'am.
Yes,
Okay. Okay.
Can you hear me, ma'am? Ma'am,
Yes, Hariharan.
my Wi-Fi is very slow, ma'am. Was the answer
Okay.
D,
Okay,
ma'am?
okay, never mind. But Hariharan, have you understood everything?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay. So what is happening in school now? Is it holidays now?
Holidays, ma'am.
Okay. Okay, please read from the textbook. Okay, then bye.
Thank you, ma'am.